Okay, so welcome to another video. We're going to solve the problem 8.5 from the book of Ken Block, the Business Statistics for Contemporary Decision Making, 6th edition. Okay, so another reminder, please guys, if you already watched the video, please pause the video and then answer the problem on your own. That is how you check if you really understand the concept behind solving this particular problem. Okay, so let's start. So once again, before you read the problem, don't waste your time reading the problem directly. Try to imagine what the problem is asking using the framework the Raymond framework here, and then every time you read some values, you put the values in the framework. Okay, let's start. So a random sample of 39, that's the sample size, n is equal to 39, is taken from the population of 200 members. So that's 200 members is the population size. So that's the n is equal to 200. The sample mean from these 39 respondents is 66. Of course, that's sample mean 66. And then the population standard deviation is 11. Construct a 96% confidence interval to estimate the population mean. And then what is the point estimate of the population mean? Simply saying here, the point estimate is the 66 here. We're using the 66 to predict the value of our population mean here. Okay, so let's start. And then of course the alpha here is 0.04, which is the confidence interval, since that is 1 minus 0.96. The decimal form here is 0.96. So that is 1 minus 0.96. The level of confidence is 0.04. And then using this data here, we're going to predict, or we're going to determine, to estimate the mean, the population mean. Okay, so since the population mean is, the population size is given as 200, we have to use this formula here with the finite correction factor. Okay, so but before that, we have to solve the value of our z-score here, the 96%, or in this case here, the 0.04. But guys, we have to remember that in confidence interval, we have to divide the alpha here divided by 2, because in confidence interval, we have to consider the two tail here. That is why in this distribution plot here, the 0.2 here, the 0.2 here, and then after that afterwards you look the value of 0.02 in the z table, 0.02. So that is around, okay, that should be around here. So we can use the interpolation to get the exact value of 0.02, but we can simply estimate the value using let's use this one here. This is approximately also 0.02. So that is negative 2. So the decimal place is 2.05. If we're going to go back, negative 2.05, very close. Okay, and then we have to substitute the value. So 2.05, and then don't worry with the positive sign, because that is symmetrical. If that is negative 2.05 here, that is also, of course, 2.05 positive side here. Okay, just simply substitute the value, and then we can solve for our confidence level of 62.7. The population mean is greater than 62.75 but less than 69.25. Okay, as usual, if you're going to give these results to non-mathematics person, so it's very difficult to understand. So we can say that we can estimate the population mean ranging from 62.75 to 69.25. How sure are you? We are 96% confident that is the range of our population mean. Okay, so please study guys, good luck and God bless.